All right, here we go. Quiet, please. Again, I'm recording this. All right, so the first blank up there, it says a system of inequalities is, well, it's just two of the linear inequalities we had yesterday. So this is two linear inequalities with two variables. Okay, so if I can get this where you can see it. Okay, so it's two linear inequalities like we had yesterday with two variables. So then on number one, we started like this yesterday. You had to plug in the x and plug in the y and then see if it made a true or false statement, right? If it made a true statement, then it was a solution. If it made a false statement, it was not a solution. Well, now you got to plug it into two of these. So what you want to check, when it says check the solution for number one right there, what you have to do is you have to plug -1 in for x and -3 in for y into both of those inequalities, and you need to make both of them true at the same time for it to be a solution. If they're both false or one of them is false, then it's not a solution. So we're going to plug these in. So the first one, let's see, you're going to put -3 in for y, and then that has to be less than or equal to -3 times the x, which is -1 plus 1. And might as well set up the bottom one also. On the bottom one, again, you're plugging in the -3 for the y, and then that's got to be less than 2 times the x, which is -1 plus 2. So then this top one, on the left side, you got -3. And on the right side, you have got -3 times -1. That's a +3 plus 1. That would be 4. And on the bottom one, you got -3 on the left-hand side. And that's got to be less than, on the right-hand side, you got 2 times -1. That's -2. -2 plus 2. That's 0. So then, what about those two? Are they both true or are they both false? Is one of them false? What's that? Yeah, they're both true. The top one is true. -3 is less than 4. And then the bottom one is also true. -3 is less than 0. So these are both true. So this one's true. This one's also true. So if they're both true, then yes, that's a solution. So you'd write -1 comma -3 is a solution. So really, that's nothing different than what we did yesterday. It's just you got to do two of them. And then you need them both to be true to be a solution. Let's try number two. Same thing. So number two, this time we got to plug in 5 for the y and -1 for the x. So plugging it into the top one, we'll substitute in 5 for the y. That has to be less than -2 times the x, which is -1 minus 1. The bottom one, again, we're plugging in 5 for the y. That needs to be greater than or equal to the x, which is -1 plus 3. So then the top one becomes, on the left-hand side, we got 5. On the right-hand side, we got -2 times -1. That's a +2. +2 take away 1. That's 1. And then on the bottom one here, we got 5 on the left-hand side. That's got to be greater than or equal to -1 plus 3 is 2. So what do we got on this one?
It's not true. It's not.
Which one's no good? Yeah, the top one, right? Yeah, the top one is false. 5 is not less than 1. So that one's false. The bottom one's true. 5 is greater than 2. So the bottom one's true. But in order to be a solution for the system, it's got to make both of them true at the same time. So this point then is not a solution. So negative 1 comma 5 is not a solution. And again, in the homework, you just write yes or no. Either yes, it's a solution, or no, it's not. You guys good so far? All right, let's do a couple of the graphing ones. I mean, it has, what, 5 of them we're supposed to graph? Let's just graph the first 2, and then I'll talk about what's going on with the next 3 and kind of really quickly go over those. But we'll go over the number 3 and 4 completely. So 3 and 4. All right, so follow my steps that I got on the board up there. So first thing we're going to do is we're going to change the inequality to an equal sign and locate the line. So the top equation here, the top linear equation, we're going to change this to y equals 3. Well, what does y equals 3 look like? That's good. Ethan said it's a horizontal line. Yes, y equals 3, that's a horizontal line. If it was x equals a number, then that would be a vertical line. And then you also got to look on here and decide whether this is dotted or solid. So when you look on here, is it dotted or solid? Yeah, it has the equal to bar, so it's going to be a solid line at y equals 3. So let's use some colors on this thing. Let's go, what should we do? We'll do this. So we've got at y equals 3, we've got a solid line. And then, what point do you want to test? Yeah, we'll test 0, 0. So we're going to test that in the original inequality. So if we test that in the original inequality, if we test 0, comma 0, we're just going to plug in 0 for the y right here. The y coordinate would be 0. So we're going to plug in 0 for that y in the original inequality. So that would just say 0 is less than or equal to 3. Is that true or false? That's true. So we picked the point down here, right? And it made it true, so we shade that side. So we're going to shade that in, kind of like this. Okay? Now we got to do the second one on the same grid, okay? So on the second one, again, we're going to change this inequality to an equal sign. So we're going to write y equals negative x plus 3. So what's my y-intercept? Yeah, it's 3. So my y-intercept is right here, positive 3. So let's use a different color for this one. We'll use red. So my y-intercept, I hit the y-axis at positive 3. And then what's my slope? What number's out in front of x?
-1.
It's a negative 1, and then that would be over 1. So where would I go from my y-intercept there? The one, that's good, yeah. Down 1, right 1. So my slope is right here again. My numerator tells me if I go up or down. Since it's negative, I go down. So I do go down 1, right 1. So if I go down 1, right 1, that's going to be like here, there, there. I could go up 1 and left 1. So it kind of looks like that. I got to grab a ruler here, though. Okay. So now what about on this bottom line? Is this right here, is that dotted or solid? That's dotted. If it doesn't have the equal to bar, it's got to be a dotted or dashed line. So let's make a little note of that here. So this thing has no equal to bar on it, so I know that this is going to be a dotted line. All right, so I got to draw a dotted line through those red points. So let me do that. That is going to look something like Something like that. Now we got to test the point. So what do you want to test? You might as well test 0, 0 again. Now 0, 0 is over here, right? So we're going to test 0, comma 0. And where we test that is in the original inequality. So I'm going to be putting 0 in for this y right here in the second linear inequality, and I'm going to put 0 in for x right there. So that would look like 0 is greater than negative of 0 plus 3. Well, the negative of 0 is just 0. So that just says 0 is greater than 0 plus 3, which is 3. Is 0 greater than 3? True or false? That is false. By the way, on that first one, I forgot to write that this one was true, wasn't it? I forgot. I said it, but I didn't write it. So when we tested 0, 0 in the first or the top inequality, it was true. But when we tested 0, 0 or 0, comma 0 in the second inequality, it was false. So if I pick the point here, right here at 0, comma 0, and it made a false statement, then which side do I shade?
The top, right? The top.
Yeah, I shade the other side. So if I pick the point and it makes it true, I shade the side where I picked the point. But if I pick a point and test it and it makes a false statement, then I shade the other side of the line, okay? So I shade the side, the other side where I did not pick the point. So that would look like, let's see, how do I want to do this? Probably like this. So that would look like this. Can you guys see where the double shaded part is? So you're looking for the part that is red and blue. Can you everybody see that that's over here? So it's like you got 4 regions there. This region is not shaded at all. This region down here is just blue only. This region up here is just red only. We want the part that's red and blue. So if I let me draw you a little sketch of that to the side. So sometimes this helps. Let's see, what did this look like? A solid and a dotted. Okay, so what you had here is you had something like this. You had a solid line, and then you had a dotted line. And then the double shaded part ended up in here, right? So that's really where your solution is. That makes sense to you guys? And then do you think on this one, could you guys write down, could you tell me the coordinates of a point that's in the double shaded region? So somebody give me the coordinates of a point somewhere in here.
4, comma 1.
Let's see, 1, 2, 3, 4, 1. Yeah, I think that would be in there safely. 4, comma 1. Let me make sure. Yeah, that'll work. So a possible solution here would be, let me see if I can draw it in there. So 4, comma 1. That is 1, 2, 3, 4. I usually don't like to pick one too close to the line, but I think that's good. 2, 3, 4. That's like right there. So that point right there, I'll kind of draw an arrow to it. That's a possible solution. That's at 4, comma 1. All right. All right, now I'll kind of go through number 4 the same way, but then the next 3 examples, I'm just going to kind of go through and tell you what's going on with those without going through them in detail. So let's look at number 4. So number 4, we got to graph both of these. So the first thing I'm going to do, according to my 3 steps I have on the board up there, is change the inequality to an equal sign and locate the line. So that top line up there, I've got negative 3x plus 2y is equal to 2. That's going to help me locate the line. Now this one I want to solve for y. So how would you solve that for y? Yep. DeJuan said plus 3x, so I add 3x on both sides. These will cancel out on the left-hand side, and I got a positive 2y is equal to a positive 3x. And then that's a positive 2, so I'll write plus 2. And then how do I finish solving for y? Got to get the y all by itself. Do what? Yeah, divide by 2 on both sides. So if I divide the left side by 2, I got to divide every term on the right-hand side by 2. These 2's will cancel, and I'll get y equals 3 over 2x plus 2 divided by 2 is just 1. So where do I start my graph at? Here, let's do this one in blue again. So we're going to do, this one is going to be the blue one. So where's my y-intercept? That's 1. Here, I'll write them, well, I'll leave it. So my y-intercept is 1. It's positive 1. So that is going to be right here. And then my slope is what? It's 3 over 2. So I go up 3, right 2. From that point I already plotted. So from my y-intercept, I'm going to go up 3, right 2. And then I'll go up 3, right 2 again. I could go down 3 and left 2. All right, I'm going to graph that line. And then looking at this right here, is it dotted or solid? Yep. Yeah, if you look at this right here, that does have the equal to bar, so it's a solid line. So let me get my ruler here. Oops. So something like this. All right. So we decided that it was a solid line. That was step 2. And then step 3 is we got to test the point. So what point you want to test? Test 0, 0. So we're going to test 0, 0 again. We're going to test that in the original inequality. That's this one up here, the one I circled in blue. So then that's going to give us a negative 3 times 0 plus 2 times 0. And then it's got to be greater than or equal to 2. What's negative 3 times 0 plus 2 times 0? It's just 0. So the left side is just 0, and then that's got to be greater than or equal to 2. Is 0 greater than 2? No, so that's false. So my test point was right here at 0, 0. And I got a false statement. So which side do I shade? The other side. So the side where I did not take the point. So let's shade that in. So that's going to look something like this. All right. Then I got to do the other line. Well, the other line is pretty much set up to go, right? The second line here, I'm just going to write y equals 4x plus 3. So that's a 4 over 1 is my slope. So my y-intercept on my second line is what? It's right here. It's 3. So my y-intercept on my second line is 3, so that's going to be 1, 2, 3 right here. And then from there, I got to go up 4, right 1. Okay, because my slope right here is 4 over 1. So I got to go up 4, right 1. So up 4, right 1. I could go down 4, left 1. I could do that again. So down 4, left 1. All right, I got to graph that line. And then what about on this one? Is that solid or dotted? Yeah, that does not have the equal to bar, so this one's going to be dashed or dotted. All right, so I got to make a dotted line. Oh, sorry. It's hard to put the ruler onto the iPad. Oh, come on. Let me try turning it a different way. Maybe that'll help. There. Every time I touch this ruler on here, something's getting messed up. I think I got it. So that's, no. Now what happened? All right, I think I got it. All right, so there's that line. All right, what point you want to test? Test 0, 0. So we're going to test 0, 0 right here. I'm going to plug 0 in for x and 0 in for y. And I'm going to plug that in this original second inequality right here. So if I do that, that's going to say 0 is less than 4 times 0. If I could write. 4 times 0 plus 3. 4 times 0 is 0. So the right-hand side is just going to be 0 plus 3, which is 3. The left-hand side is 0. Is 0 less than 3? Yes. That's true. So then I shade the side where I pick the point. So I picked the point over here. So that means I got to shade the right side of that red dotted line. So let's try to do that. That's going to look something like this. These get kind of messy. Can you see where the double shaded part is? The double shaded part's at the top up here, right? That's your solution, is the double shaded part, including the points that are on the solid line, but not including the points that are on the dotted line. So again, this region over here is just blue. That only solves the top inequality. This region over here is just red. Those points only satisfy the bottom inequality. This region down here is not shaded at all. Those points in there, those don't satisfy either of the original linear inequalities. So our solution's up here. So again, if I could draw you a little sketch of that, just so sometimes people see it easier like this. What we got is we have a solid line, and then we have a dotted line. And our solution is actually in here. Does that make sense to you guys? All right. Now these next 3 problems, let's just try to go real quick with them, okay? I'm just going to sketch them really fast for you guys, and you can see what's going on, I think. So all these are is I mean, they don't need to learn anything new to do the next 3 examples. They are just special cases. So let's take a look at them, why they're special real quick. What do you notice about the slopes? Like, what's the slope of both of those lines right there?
2.
Almost. What's the slope of both lines?
Negative 2.
-2. So the slope is the number in front of x, right? So both of those slopes are -2. So what kind of lines does that make then?
Parallel.
Good, they're parallel. Look at number 6. What are the slopes? 3. They're both 3, so those lines are parallel. Now they have different y-intercepts, so one line is going to be above the other line, okay? The bottom linear inequality, that one, would be above, that graph of that line would be above this one right here because this one has a y-intercept of 6. This one has a y-intercept of -2. And then number 7, what do you notice about the slopes? What are they? They're what? But what are the slopes? Yeah, the slopes are both 4. So again, those are going to be parallel. This bottom inequality is going to be a bottom line because it has a -5 for a y-intercept. This one, the top one, has a y-intercept of +6, so it's going to be above. It'll be above the bottom line. Now let me just try a quick sketch of these so you can see what's going on. All right, I'm not going to get real particular here. I'm just going to sketch them really fast. You ready? So let's say, I'll go as fast as I can here. So let's say we got a blue line here. Let's say this one's going to be in blue. It has the equal to bar, so it's going to be solid. It's got a slope of -2. It's got a y-intercept of -4. So it's going to be down here somewhere, okay? And then the other one, we'll do that one in red. This one's going to be a dotted line. That also has a slope of -2 and a y-intercept of +5. So that's going to be up here somewhere. But it's going to be dotted. And if we went through all the work, what we would find is that the red one would be shaded above. Ethan, stop that, please. And the blue one, if we did all the work on that one, we'd find that that one is shaded below. So then, where's the double shaded part?
There isn't one? No
So,
solution.
so no solution. All right, the points that are solutions have to be in the double shaded part. So this one would have no solution. And again, I'm kind of skipping all the steps on you guys here. But again, it's just the same process we've been doing yesterday and today. It's the same 3-step process that I have on the board up there. Let's look at number 6. So in number 6, I'll do this one really fast again. The top linear inequality, that's a dotted line that goes through a y-intercept of -2 with a slope of up 3/1. So it would look something like this. And again, that's not a very good drawing, but this is just to show you what's going on real fast. And then the bottom one, that's a dotted line also. Same slope, but going through a y-intercept of +6. So that one would be like up here somewhere. So they're supposed to be parallel. I didn't do a very good job. Maybe I can fix this real quick. So something like this. Okay, and then what happens is, the top one gets shaded above, which would look like this. And then the bottom one gets shaded below, which would look like this. Where's the double shaded part? Where's the double shaded part on that one, you guys? How would you describe it? Where is it red and blue? What's that? Say it again. In the middle, yeah. In the middle. All right, so it's the points that are between the two dotted lines. Do you see that? That's your solution. So again, if I sketch that to the side here for you really quick, it would just be like you'd have this dotted line, and you'd have this dotted line, and then your solution would be all these points in here, right?
So all the numbers?
No, just the points, the coordinates of the points where it's double shaded. Rachel, there'd be infinitely many points. but they got to be the coordinates of the points that are in between those two dotted lines. All right? And then number 7, same thing again. We got same slope, right? Both of these are got a slope of up 4 over 1. The top one's got a y-intercept of positive 6. So that would look something like this. The bottom one is parallel to it with a slope of up 4 over 1, but it's got a y-intercept of negative 5. So it'd be something like this. Again, that's pretty crappy, but they're supposed to be parallel. The blue one, the top one, that one you would shade above it. So that would kind of look like this. And then the bottom one, that one you would shade above it also. So that would look something like this. Oh, wrong color. Something like this. Where's the double shaded part? Not in the middle. Where's it blue and red? Where? To the left. To the left of the blue line, right? So again, if I draw you a little sketch of that one, you'd have the two parallel lines. And the double shaded part would actually end up over here only. Did that help? So the double shaded part would be over there. So any point in that double shaded region would be a solution. All right, let's do the story problem. We're done. So hopefully that sped things up, because if I would have graphed all those and went through every single step and all the details, that would have took forever. But it is the exact same steps that you used yesterday and today. Same process. It's that 3-step process that I have on the board. So let's do the story problem. So the story problem, this one I almost misread it earlier. It says you're buying pounds of pepper jack cheese and cheddar cheese for a party. You want at least 2 pounds of each, but you want to spend at most $20. And then the pepper jack costs $4 per pound. The cheddar costs $2 per pound. And then we're going to graph this solution and write these two inequalities. Well, actually, there's 3 of them. Because the first time I read this as at least 2 pounds. Well, I thought they meant 2 pounds total, at least 2 pounds total of the cheese. But that's not what it says. It says they want at least 2 pounds of each. So that means you want the pepper jack, the number of pounds of pepper jack, to be at least 2. So that's got to be greater than or equal to 2. And then you want the pounds of the cheddar to be also at least 2, which would be greater than or equal to 2. So you've actually got 2 inequalities there. And then the next inequality involves the money. So it's $4 for each pound of the pepper jack, plus it's $2 for each pound of the cheddar. And then you want to spend at most $20. How do you write that? How do you write at most 20? Yeah, so that'll be less than or equal to 20. So you're going to have 3 inequalities here. We got to look for the triple shaded part. Now, when we start to graph these, you got to think a little bit. I said the first step up there on the board is to change the inequality to an equal sign, right? So that means you're going to think of this first one as just P is equal to 2. But then again, the way I'm setting this up, the P, if you look over here on the right, the P is the same as your X, right? So the pounds of pepper jack is on the x-axis. So that's the same thing as graphing x equals 2. And then this one, you're going to change it to an equal sign. So that's going to be C equals 2. But the C is like your y. the number of pounds of cheddar, that is on your y-axis. So that's y equals 2. And then the third one, this one, you're going to change it to an equal sign. So you're going to write 4p plus 2c equals 20. And I think the best way to graph that one is with the intercepts. So this is going to be p and c. You're going to plug in 0 for p, and then you're going to plug in 0 for c. So if I plug in 0 for p, then I would cover this up and solve for c. What would you get? What's that? 10, right? You divide both sides by 2, so you get 10. So this would be a 10. And then you're going to plug in the 0 right here. You're going to plug in this 0 for c right here. So you're going to cover this up. And you're just going to solve 4p equals 20. What do you get for that one? Yep, 5. You divide both sides by 4. And 20 divided by 4 is 5. So this would be 5. All right, so now I think I got enough information that I can start graphing this thing. Yeah, please don't do that, okay? All right, so let's go with the top one. This one, let's do it in blue. The middle one, let's do it in red. This bottom one, let's do it in green. So we're going to be looking for the part that's red, blue, and green. And then taking a quick look at what kind of coordinates I need here. I need to get to 10 on the y-axis, and I need to get to at least 5 here on the x-axis. So let's, I think I'm going to draw my own grid on this one. So let's draw this thing. Let's see if I can draw this halfway decent. So we need a grid here, something like this. We got to get up to 10. So we got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we need to get to 5 on this axis. So we'll go 1, 2, 3, 4, 5, 6. So there's 5 right there. Okay, now the first one. So this one right here. How do I graph p equals 2? Which is the same thing as graphing x equals 2. Is that a vertical line or a horizontal line? That is a vertical line at x equals 2. And then you can see I have the equal to bar on here on all 3 of them, so they're all going to be solid lines. So the top one I said I would do it in blue. So I need to draw x equals 2 in blue. X equals 2 would look like this. That's not very straight. We'll call that good. All right. And then what point are we going to test in that one? Test 0, 0. And we're going to test that in this original inequality up here. So that's going to be a test of 0, 0. Which means I'm going to plug 0 in for the p. And that thing is going to say 0 is greater than or equal to 2. Is that true or false? That is false. So 0, 0 was right here. That made it false. I got to shade the other side. So I'm going to shade this way. Okay. And then the other one, I got to graph c equals 2, which is the same thing as y equals 2. So what do I got to do? Is that a vertical or horizontal line?
Horizontal.
That's a horizontal line at y equals 2. And for that, we said we'd do that one in red. So I got to draw a horizontal line at y equals 2 in red. So that would look something like this. I'm going to test 0, 0 again right here. So if I do that, whoa. If I do that, I'm going to test 0, 0. And I'm going to put 0 in for C. And that's going to give me 0 is greater than or equal to 2. Is that true or false? That's false again. So then This point didn't work, so I got to shade the other side. So I got to shade it like this way. I got a bunch of colored pencils in my closet. Would probably help you guys. There we go. So that looks like that. Then I got to graph the third line. So the third line is the one in green there. And for that one, I said I was going to use these 2 points, 0, 10 and 5, 0. And I'm going to do that one in green. So 0, 10 is right here, and 5, 0 is right there. So I got to graph a line like that. That's pretty hard to see. Maybe I'll make that a little more bold so you guys can see it. That's that one. All right. Not the straightest graph in the world, but I think it'll do. All right, then we're going to test 0, 0 again. And we got to test it in that green original inequality right there. So we're going to test 0, 0. Well, hopefully you guys can see by now that, well, I'll write it out for you. It's 4 times 0 plus 2 times 0 is less than or equal to 20. Well, the left side is just 4 times 0 plus 2 times 0. That's just 0. 0 is less than or equal to 20. Is that true or false? That one is true. So if that one's true, then I'm going to shade the side where I picked the point. So that means I got to shade this way. Let's see, how do I get these to cross halfway decent? Maybe like this. That's getting kind of ugly. Can you see where the triple shaded part is? You're looking for the part that's green and blue and red. Where is it?
In the triangle.
Yeah, it's in the triangle. Do you guys see it? So here, I'll shade it in for you guys. We're in this little triangle right here. Here, I'll outline it. It's this triangle right there. So it's all these points in here. Which looks something like that. Can you guys see it now, okay?
Yep.
Now, can anybody tell me a solution in there? 3, 3 looks pretty good. So if we do 3, 3, I don't know if we can see it or not. 3, 3 is going to be 3 right and 3 up. That's going to put us about right in here. I don't know where, I'll draw an arrow to it there somehow. So that 3, 3 would be a possible solution. That would mean 3 pounds of pepper jack and 3 pounds of cheddar. All right. Again, that's not too easy to see, but that's the best I can do.